morning, everyone. I'd like to thank everyone for taking the time out of the day to come here and listen to our presentations. We've all been working pretty hard for the last couple weeks to get our capstones completed in time for this little event. So, without further ado, I will go ahead and start my presentation. My name is Ben Klein, and I tried to create a portable mesh network. So, before I get into the product, uh, I'd like to just kind of share a little bit about myself. I'm a former Marine. I served from 2005 to 2010. I worked in aviation electronics, so the military is what really got me into working with electronics in general. And ever since then, I've been just kind of tinkering with things at various jobs and getting into trouble, and that's kind of how I ended up here. So I ended up getting this idea based off of a former students of Brian's named Sage Martinez. He created something for search and rescue, which was a delivery type system to get first aid and communications to individuals that are in need before search and rescue can actually get out to them. And thinking about everything that he did and what was going on with it, I kind of thought a little bit more about uh, how fickle communication can be between between point A and point B, especially somewhere out in the wilderness. So I ended up thinking about creating a mesh network that's deployable out pretty much anywhere you need, and it'll allow any sort of communication between the device, hopefully where the individual in help is at, and transmit that data reliably back to a ground station. So some of you might not know what a mesh network is, and a mesh network is basically just a various number of nodes, all connected to each other and all working to try and get communicate or to get data from one location to another. So in this particular graphic, you see node A at one point trying to send data to node B somewhere else in the mesh. And so everything's going to try and get help the data move along to point B. One of the nice things about mesh networks is if, say, one of the nodes that stops working on the main route, they can create an alternative route to ensure that the data gets to where it needs to be at. So I ended up going with a company called Digi and a product called XB. And the reason why I did this was because of three main factors. The first one being that it already has mesh functionality in it, so I don't have to try and create something out of nothing. The second one is that from what I could find, there seemed to be multiple libraries that I would be able to use and reference for my coding needs. And the third one is doing a bit of research. It looked like it had been mentioned and was in several forums. There are several YouTube videos I could go to and a couple other websites so that if I couldn't find something in the documentation, hopefully I could see someone else had the same problem and see how they resolved it. So right away, all of that seemed to backfire, minus the Digis actually talking to each other, which was great. So this is just a quick video showing that I was able to get a microcontroller to talk to another one of the XBs hooked up to a computer uh, in its own little ecosystem. So this is just it doing its thing, and all I wanted to do was make sure it said "Hello World," and it was able to send the packet across and be received perfectly intact. So once I was able to verify that I had a consistent signal, I went for a little walk around the facility and off as far as I could to see when about I would start losing a reliable signal. So as you can see, the 0 up here is where we're currently at, the fuse maker space. And I was able to get an okay distance away, about 1,200 feet, before I started really losing a lot of data. And so that's kind of the benchmark that I had set initially. So with that being done, I needed to create a program to start sending data. So I went through the libraries and tried to follow those to hopefully make the experience a little bit quicker. And I was not able to get any of the libraries to work. And I could not figure out why. I did a little bit more research and I even asked the instructors to give me some help to make sure it wasn't just me being a complete potato. And come to find out, it was not me being a complete potato. It just was not going to work with the equipment that we had. So I went about creating everything from scratch, using the libraries as reference material and the documentation to see how everything is supposed to be built. I was able to more or less build what I needed. There were a couple of hiccups. The first one being in the library that I found, uh, they had an extra little bit that shouldn't have been there. When I referenced it with the software, it looked correct. That number is 14, and so I went along with it. So just trying to send a couple of packets with nothing in them seemed to work, but the instant I put anything in it, it stopped working. Well, the reason it stopped working is because the checksum was incomplete. Well, I guess not incomplete, it was wrong. What ended up happening is the checksum is what ensures the packet's integrity. So if the checksum is wrong when it's received by the receiving unit and it sees it's incorrect, it's just going to toss it out. So nothing got sent. And what I ended up having to do is figure out how a checksum was built for this particular application, go through several packets and compare it to how the software builds it and see what the difference is. Well, the difference was more than that 14 actually. It ended up being an 18 value difference. So I just had to modify that little section and it resolved our issue. So this is the dashboard, and you'll see some information pop up on the right. That's the feed of the dashboard coming in saying I have new data. If you look here up on the left, you'll see a little blue dot that showed up on a map. So as I zoom in, you will be able to see this is roughly the GPS location that was received and placed on the map. This little building is where we are, and for some reason the blue dot is on the other side of the parking lot. Uh, this building is a big Faraday cage. I was just happy that we actually got something within a couple blocks, to be honest. So with all that being done, I set out to build what I needed to for this particular project. Unfortunately, I wasn't able to get everything that I wanted, but I was able to produce something that is functional. So this individual in the center is the receiving module. Whenever it gets a signal, it will just print out the GPS location and send the information to a dashboard for this particular use case. This big one right here is actually the GPS remote. I wasn't able to get it any smaller, but I was able to ensure that it had a battery pack, it's rechargeable, and it is able to consistently transmit the signal every time the button is depressed. And this guy over here is basically just the additional mesh that's needed. There's no special programming to it. It just has a couple of settings changed in the software and hooks up to a battery and is just always on. So with that being done, I went out to a nice hiking spot. I left the receiver in the parking lot. I was able to get about to where the water tower was before I lost signal with the GPS transmitter. And so that's where I ended up leaving the mesh node. So this little video is just kind of show you the first area where we'll lose line of sight, or this is the last place with line of sight. This is the last area where I have a reliable signal, so I put the node there. Just show you, you can't see the parking lot from here. From up here, just kind of showing you, I went out a little bit further near those power lines, and this is around the last place that I was able to get reliable signal, and I was able to transmit the GPS coordinates from there
to the parking lot. I believe this type of equipment or this type of mesh network is something that can easily be added to pretty much any industry for whatever data you're trying to collect. Because they're low powered, they can be encrypted data. You can easily get live data from pretty much whatever you want. As long as you have enough nodes within reach of each other, the data will get sent to wherever it needs to get sent. So, for example, say a city needs to get air sample data from a specific part of town, or um, any other kind of general data that they want, as long as they're all close enough to each other, you can easily tie them into existing infrastructure, such as light posts, turn signals. You just tie in power to that, and they'll collect whatever data you need and transmit it to wherever the central location is. The same with, say, farming or a plant nursery. If you might have a problem area, or you're looking for very specific data on light, or how moist or how dry certain soils are, if it's missing a particular type of mineral, you can just set up a sensor to these types of units, and as long as they're all within reach of each other, you can have acres and acres of data collecting, all from just this pop-up mesh. And with that, uh, I want to thank everyone for spending their time listening to our presentations. If anyone has any questions, I would be more than happy to answer them.